Guys, I'm going to show you a quick tutorial on how to do the dilution math for part 2 in your lab number 3. So the first thing you need to know is you need to know the stock concentration. So I'm going to come up with a hypothetical 0.80 molar copper sulfate solution. This is not what you have in the lab. Yours is different, but this is just my example to show you how to do the math. The equation to do dilution problems is M1 times V1 equals M2 times V2. M standing for molarity, V standing for volume. So you multiply whatever you call the 1 value, and I'll talk about that in a second, and the 2 values together, and we can solve for either any variable here, just doing a little algebra. So here is an example. So say you got this stock solution of 0.8 molar copper sulfate, and we want to make a dilution where we're going to cut it in half. That's how we say that the dilution concentration should be 0.4 molar, right? Okay, so what do we do for this? So we're going to take some of the stock and we're going to add water to it. That's because the concentration of the dilution is lower than the stock. So the only way to do that is to take some of the stock, add some water to it, and thereby lower the concentration. The real helpful part of this is you need to know what your final volume is going to be, or your V2, before you can do this math. So we're going to say that our final volume that we want is going to be a 10 milliliter sample. Okay, so we want a 10 milliliter sample at 0.40 molar. Therefore, we're calling this the M2, or my second molarity. My stock solution at 0.8, that's going to be my M1. Okay, so the only thing I don't know now is V1, which is how much of this stock do I take and then add some water to it to get it to be 10 milliliters. So here's how it works. All right, I've identified M1, M2, and V2. So the only unknown is V1. So I'm going to just plug these in now to the equation. So 0.8 molar, again, is my M1, times V1, which I don't know just yet, equals M2. This is my dilution concentration that I want. My final volume is 10 milliliters. Okay, so there's the setup. To break up this side, to get V1 by itself, I have to divide both sides by 0.8. So now we have 0.4 divided by 10. Sorry, not divided. 0.4 times 10 divided by 0.8, and we should end up with, doing some math, hang on, V1 equals 5 milliliters. Now notice I kept this in milliliters when molarity really is moles per liter. You can do that. You don't have to convert it to liters if both volumes are in milliliters. That's totally fine. You can convert it to liters if you want. You'll get the same answer, okay? All right, so this is my V1. So this is 5 milliliters of the stock of that 0.8 that I need, okay? So you should recognize 5 milliliters is not equal to the final volume. The final volume is 10 milliliters. So if I have 5 milliliters stock and I want 10 milliliters total, how much water do I add? Well, pretty easy math, right? If I have 5, I want to get to 10, so I'm just going to add 5 milliliters of H2O. So 5 milliliters of H2O, 5 milliliters of the stock will get me my 10 milliliters of my final. That's what you want to do in the data table that you have for the lab. Let me show you that again really quick. Okay, it's right here. Whoop, turn that. So if you look, well, sorry guys, I'm getting all topsy-turvy here. So here's what you are given already. So this is your stock solution, the 0.4 molar copper sulfate. That's what you made today. For your first sample that you're going to run tomorrow in the spectrophotometer, you have 8 mils of that, no water. What you need to figure out is how much of the stock and how much water for each of these different concentrations. So these are going to represent here your M2s for different dilutions. This is your M1, the stock concentration. What volume should you make? You should make it for 8 milliliters, or V2 should be 8 milliliters for every single one. Okay, so they should all be 8 milliliters. Hope that helps. I'll talk to you tomorrow about it if you have questions.